For calculations involving gas chromatograph, there are a few formulas that all of you need to be aware of. The first and foremost is the number of peaks that you see on the GC spectra. That would be equivalent to the number of constituents or compounds in that sample mixture which you have injected in the GC. The second and the foremost is the order of peaks. From the point of injection, the first peak that you would observe, no matter what the size and height, is the peak of the compound with the lower boiling point. As you move away from the point of injection, the boiling points will keep increasing. So this is something that you always have to keep in mind, that order of peaks on your gas chromatography spectra is dependent on the boiling point of that material. The next formula belongs to retention times, abbreviated as RT. This is calculated as the distance of the peak from the origin and has to be calculated in or measured in centimeters. This is also divided by the speed of chart. Now, the speed of the chart can be given to you in the question itself or on the graph. So you will have to look carefully.
So for example, this particular sample, I will see the distance from the point of injection to the center of this peak. And I will record this as the distance of the peak A. Let's label it as A from the origin. Retention time actually defines how long it takes for the compound to be retained in the column. So for example, if we increase the column length, the peak or the sample will come out later, and the distance of the peak will also increase. So retention time changes with temperature of the column, and it also changes with the length of the column. The next formula that all of you need to be aware of is area under a peak. This is calculated again using a ruler, the height of the peak. And as all of you know, what is height? It is the highest point of the peak times the width of the peak. Now, the width of a peak is always calculated or measured at half of the height. So if your height of the peak is 10 centimeters, what is the width at 5 centimeters? That width you have to multiply with the total height of that peak. So let's calculate area under one of these peaks. So let's say this is peak A, peak B, and peak C. And we wanted to figure out the area under peak C. So you are going to find the highest point of this peak. Place your ruler at that place and figure out the height of the peak, the total height of the peak in centimeters. Since the total height is this, I will divide the total height by 2 and figure out half of that height. I will now take my ruler and very carefully observe the width at half this height. Now, this may be a very small number, so you do not need to be alarmed. But since we are using a centimeter ruler, you need to be recording the appropriate numbers. To figure out the area under this peak C, I will multiply my height and the width at half the height to figure out the area in centimeters square for this particular peak. Once I calculate area under one peak, in the similar fashion, I will calculate the peak area under all the peaks. Let's say that I have a sample with only two peaks, peak A and peak B. What is the total area of all the peaks on that spectrum? What I would do is I will add all the areas under every peak and just use that as my total area of the spectrum. Now, a point to note is the area under the peak can change. And the thing or the factor that can change the area under peak is the amount or the volume injected. If you inject a lot, you will have a bigger area. If you inject very less, you will have a small area. From total area and from knowing individual areas under every peak, you will be able to figure out the percent composition of that particular compound. How would you know what is your compound? Again, that is dependent on the order of peaks. Lower boiling compounds will appear first, closer to the point of injection. Higher boiling compounds would appear later, away from the point of injection. So you will take the area of that particular peak, whose compounds percentage you want to figure out, and then divide by total area. Multiplying by 100 will give you percentage. So if you have three peaks, you will be using three areas. If you have two peaks, you will be only using peaks A and B, or whichever you want to label as your area.